Hey guys, alright, today we're gonna talk about modifying and creating a lexical scope during runtime. And this past few videos, we talked about um, the lexical scope, how it is created during the compile the author time, and we compared it to what dynamic scope is, and we talked about how um, basically the hoisting that happens when the scope is created and how it ties in with the compile phase and then the execution phase. And these are things that we have discussed in the last few videos. So if you get confused by any of the materials that we're discussing right now, please go back and review all those videos, and a lot of these will make sense. Today we're going to talk about basically cheating lexical scope. This is one topic that I read in Kyle Simpson's You Don't Know JavaScript that was really interesting to me. It was very interesting because it's not useful, but I thought this really would help to really understand what's going on. So here it is. Um, so we're gonna first talk about modifying lexical scope at runtime. So as you know, lexical scope is a scope that is already predetermined at author time, and then when it's done compiling, the first phase, the compiling phase, the structure and the hierarchy of lexical scope is already created. And lexical scope is this bubbles of scopes over scopes over scope. It's a hierarchy of scope chain, and it's already been created and done. So at runtime, when the codes are actually ran, how do we do this, right? So in the compile phase, it's going to look at this function declaration and then create the function, store it into the scope engine, recursively go back in, create a variable declaration for a string, stored it into the scope of blog, right? And after that, these are all not declarations, so it's not gonna involve in executing any of these. These are all RHS, which I discussed in the last video, which basically means it's looking for an identifier in order to execute, to use. So it doesn't involve to do anything in the compiling phase, and it is done after it implicitly declares a variable declaration and it exits. And this is also a RHS, looking for an identifier called login in intent to use and execute. And now we're in running phase. And in running runtime phase, this is how we could modify the lexical scope, right? So right now, inside of this function scope, right? Keep in mind that lexical scope inside is already determined, right? We already determined the variable declarations that happens inside of this function scope. And outside there is a global scope, right? So the scope chain and the hoisting of declarations stored into the scope already determined, already finished by the time of compiling phase. Now how can we modify that at the runtime? So let's go to the runtime. All of this doesn't exist anymore, right? All of these don't exist because it's been stored away into the scope engine, and now we're in running phase, runtime. We look at this code. We ask the global scope, hey, global scope, we need a RHS, right-hand side identifier called blog, so that we could execute it. And the global scope goes, yes, we have declared a function declaration for the identifier called blog and gives it back to us. And inside of that identifier block, we have this whole function object, which you execute and pass in this parameter. It's a string. We pass it in this implicit variable declaration called string. It gets stored into this string, right? Next line, we recursively go back into the function object and execute this function because we executed it. We go in and we use eval. That's the first thing we see. It's RHS code that's not intended to assign anything. It's an execution function, and what evaluate does is some people call it evil, maybe because it's evil because it's doing something that it should not do. Um, Eval basically evaluates a JavaScript code. So whatever you pass in, if it's a JavaScript code, it just evaluates it. So and executes it. So we passed in a JavaScript code, right? In a string form. We declared a variable declaration, variable focus equals focus focus. And then it's gonna go into the string, it's gonna evaluate that string, variable focus, focus focus, and it's gonna declare that variable declaration at the runtime, just like the compile it does in the compile phase. But this is runtime. It declares the variable focus, stores it into the function block, right? And then it, because we're in runtime, it even does the LHS lookup called focus to the function of scope of block and gets it, and then assign a immediate value called focus focus into that LHS focus identifier, and it stores it. So by the time we go into console.log focus, what is it gonna return? It's gonna ask blog and goes, hey, do you have a RHS reference called focus? And it gives it back to us what we have just assigned. Focus. It gives back the RHS identifier called focus, right? And inside there is a value, and we execute it, and so focus is what we're gonna get. So this is very interesting. It basically, we did the variable declaration during the runtime, because by putting it in here, this is not going to be run on the compile phase, and this is not going to be run on the compile phase. But these two things are basically modifying the existing lexical scope and creating a variable declaration and assigning it immediately. So we have this scope, lexical scope, and we're doing decorations to it at runtime. So that is why we call it modifying lexical scope at runtime. Now, that's the first one. Now, this one is creating lexical scope at runtime. This is actually creating its individual scope during the runtime. And remember, lexical scope is only created during the compiling phase. But now we're trying to create the lexical scope at the runtime. So right here, during the compile phase, variable declaration, variable array has been declared, got stored into the global scope. And at the runtime, we assign, we look for the variable declaration, LHS, left-hand side to assign. We get it, and we declare an object, right? And right here, this is with keyword, right? That actually creates this lexical scope. Inside, we could pass in an object, and we could console.log its properties, because this whole scope is based on relative to this object. So instead of doing array.woo, array.woohoo, array.0, array.2, we could immediately take out the execution context, which is the object or the variable, right, that holds the object. We could take out the execution context and just go woo, just the property, and you'll say play hard. And then we could do woohoo, that is also a property, always. And then this one, you can't just put 0, it just doesn't work that way. But this is an array object, right? And each time you put in an item, immediately under the table, with arrays, each time you put in objects, it creates its keys and stores those objects as values, and those keys are just index values that we all know about, which we explicitly put it here. So array 0 would be work hard. Now, what happens if we do focus equals yup? We might think that it's gonna create array dot focus equals yelp. It's gonna create a property for array, right? No, it doesn't happen that way. This is just a gotcha thing. It still obeys the rule of go fishing of lexical scope rule. It asks the scope of array, do you have a property called focus? It goes, no, I don't. And then it goes outside, which is the global scope, and goes, hey, do you have this LHS, left hand side identifier called focus? And they go, no, but we just created it for you. Because remember, with global scope, it treats LHS and RHS differently. If you're looking for a left hand side, if you're looking for a identifier in the purpose to assign a value to it, then that is you're looking for left hand side identifier. Then what it does is that it basically creates one for you immediately, and then you could assign a value to it. That is why it's a global variable, because it's created at the global scope and stored under the global scope. And you're assigning a value to a declaration variable that exists in the global scope. And right here, when we actually run it, right, when we do array.focus, array does not have the property. So it's undefined, doesn't have that value. And then if we just do focus, it's gonna say yup, because we created it in the global scope, and now it's the property of window object. And just think of window as an object that exists in the global scope, and every variable that has been declared and got stored into the global scope becomes property of a window object. And so focus, we're asking the window object, do you have property called focus? Or we're asking the global scope, do you have focus variable declaration, RHS? We're trying to use it, so we're looking for RHS identifier. So it's basically the same thing. If you're looking for LHS, left hand side identifier, RHS identifier, ultimately you're both looking for an identifier of variable declaration, right? Except if you're looking for LHS, you're basically saying you're trying to assign a value, so if it doesn't have it, it'll create it for you in the global scope. But if you're looking for RHS, intend to use, or it's not for assignment, then you're still looking for that variable declaration, but if it does not exist, then it will not create it for you. So just the behavior the reaction that comes to it if you don't have these variable declarations changes depending on if you're looking for LHS to assign or RHS to use. And that is just two different ways of modifying lexical scope. Controlling lexical scope during the runtime, modifying lexical scope or creating a lexical scope. And this right here is creating a lexical scope because it creates a private scope for this object, and you could just call its properties because it just automatically is in the context of this object. It's a scope for that object, so it creates this scope during the runtime. And right here, this is modifying lexical scope because at the runtime, you're evaluating JavaScript codes. That's what eval does. It evaluates JavaScript codes and executes it. And it evaluates this string and it executes it as a JavaScript code. So right here, when we do it right here, eval string variable focus happens, and then it automatically does the variable declaration, stores it at the block scope, and then does assignment immediately, and then console.log focus works. So it actually does the variable declarations at runtime, stores it at runtime, and does all of that. So therefore, we're actually modifying lexical scope at the runtime. And all of these things should make a lot of sense if you actually watched my previous videos. And this is my journey on learning JavaScript as well with Kyle Simpson's you don't know JavaScript, it's a great book. It talks about a lot of concepts. Will save you months of studying, and we'll look at JavaScript in a different way. And I'll come back. I come from Ruby background, and one of the greatest topic that he talked about is the prototype link. It has nothing to do with inheritance, or it's not. It's not class. There's no class, and there's no inheritance. There's prototype link is a completely different um, um, concept, and I think it's more powerful than inheritance, really. And um, I'm gonna talk about that as well. And these are just very basically snippets and summaries of topics that I've learned, and I'm keeping block for myself. But really, if you really want to grasp the whole concept with details, because details are so strong and important, you have to check out the book. And it's Kyle Simpson's book. Alright guys, thank you for watching. Until next time, see ya.